that the equation of the tangent to y is equal to ln of x at the point where y is equal to -1 is y equals to ex minus 2. Basically, this is just saying, instead of solving for something this time, given that equation is y equals ln of x, given y is equal to -1, the equation of the tangent line at y equals -1 is equal to ex minus 2. So first we need to know what the graph of ln of x would look like. We know that when x is equal to 0, that's undefined. What about ln of 1? ln of 1, it's going to pass through the 0. So it has an asymptote on the y-axis, pass through 1, and then it's going to increase that way. Given that y is equal to -1, what's the x value on that point? We know that equation of this graph that we just drew is y is equal to ln of x. So when y is equal to -1, what's x value? Right? ln has a base of e, so e raised to the -first power is equal to x. So the coordinate of this pink dot or red dot would be e to the -first power and -1. We want to show that the equation of this tangent line passing through this point is equal to ex minus 2. So first let's take the derivative of y so we can find the slope at any given point. The derivative of ln of x is 1 over x. When x is equal to e to the -first power, 1 over e to the -first power, that's the same thing as e, right? So now we can finally find the equation of the tangent. So y is equal to ex plus b, and we know our x and y are these. So let's just plug it in. -1 equals to e times e to the -first power plus b. We know this e has a power of 1, so when you have a same base, you add the exponents, so we get e to the 0 power plus b is equal to -1. But we know that anything to the 0 power, except for 0, is equal to 1. So b is equal to -2. So finally we have y is equal to ex minus 2, which is what's given in here. And this time let's work with some trig equations. Find the equation of the tangent to y is equal to tangent of x at the point where x is equal to pi over 4. So first let's take the derivative of tangent, which is 1 over cosine squared x. So if I plug it in pi over 4 for an x, I have 1 over cosine pi over 4, right, and then whole thing squared. We know at pi over 4, right, given a circle, pi over 4 is right in the halfway of the first quadrant. The coordinate of a cosine is √2 over 2. So squaring that, we have 1 over 2 over 4, which is the same thing as 2. So we have y equals to 2x plus b. We are given an x, we haven't found the y yet. So when x is pi over 4, y is tangent of pi over 4. What's tangent of pi over 4? It's 1, right? Because it's root 2 over 2 over root 2 over 2. So 1 is equal to 2 times pi over 4, that's pi over 2, plus b, and b is equal to 1 minus pi over 2. And you can leave your b in terms of this term. So finally we have y is equal to 2x plus 1 minus pi over 2. That's the equation of the tangent when x is equal to pi over 4. Find the coordinate of the points where the tangent to y is equal to x cubed plus x plus 2 at 1 and 4 meets the curve again. So given a curve, we need to find a tangent line that passes through 1 and 4. By now, you should be an expert at this. First, we need to find the derivative of y. So we have 3x squared plus 1. What is the slope at x equal to 1? That's just plug in the 1, right? We get 3 times 1 plus 1, that's 4. So y is equal to 4x plus b is the equation of the tangent line. We just need to plug in the 1 and the 4 on x and y accordingly. So 4 is equal to 4 times 1, that's just 4, plus b, therefore b has to be 0. So we know that equation of a tangent line is y is equal to 4x, right? So what are we interested in finding? We're interested in finding the coordinate where y is equal to 4x is going to be tangent to y is equal to x cubed plus x plus 2. So on your calculator, you're going to put in an equation of y is equal to x cubed plus x plus 2. And you're also going to put it in y is equal to 4x and see where they intersect. So x cubed looks something like this. And then it must pass through 1 and 4. So let's assume this was 1 and 4. And we're interested in finding where is the other point that's going to cut through this graph. Turns out it's -2 and -8. So I highly suggest that you try this on your own on your calculator and see if you get -2 and -8. This is going to be the last question on section A. Let's find the equation of the tangent to y is equal to x squared from the external point 2 and 3. As you can see, the word external means outside, so this point 2 and 3 is not going to lie on the graph of y. So y is equal to x squared looks somewhat like this, where it's going to have to pass through the origin and go up. When x is equal to 2, it's actually at 4. So the external point is going to be somewhere below the graph. That's going to be 2 and 3. So we're interested in finding the equation of the tangent from this external point. How many tangent lines can we get from this external point 2 and 3? We can get a one that starts here and then goes in that direction. So somewhere along this way, I can get a tangent. And somewhere going up, right, we can get another tangent somewhere up here. So from an external point, we get 2 tangent lines. Then let's think about how we can find the coordinate where this line and the curve is going to intersect? Well, we know that any point on this curve could be represented as, if you have an input of x, the output would be x squared. Right? That's coming from this. If you plug in x, you get a y value of x squared. So this blue line and then the curve is going to intersect when the slopes are going to be the same. Well, slope at any given point on this curve is just taking a derivative of the function. So we have 2x. But what about the blue line? Just like we said, any point on this curve can be represented as x and x squared, and that's going to be still remain the true on this really big blue dot. So in order to find the slope of a blue line, we have y2 minus y1 over x2 minus x1. So we have x squared minus 3 over x minus 2. That's going to be the slope of a blue line. And when the slope of a blue line is equal to the slope of a curve, that's when they're going to intersect. So we say x squared minus 3 over x minus 2 is equal to 2x, which is really just 2x over 1. So cross multiplying, we have x squared minus 3 is equal to 2x squared minus 4x. And let's move the x squared on the other side. So we have x squared minus 4x. Move the 3 onto the other side as well. So positive 3 is equal to 0. And it factors very nicely into x minus 3 and x minus 1 is equal to 0. So at x equal to 1 and x equal to 3 is when they are going to intersect. Awesome. So when x is equal to 1, that must be this blue dot. When x is equal to 3, that must be this red dot. So when x is 1, y value is 1 on this curve. When x is 3, y value is x squared, so that has to be 9. So we're almost there. We want to find the equation of two tangent lines, and let's find the blue one first. We know that slope on a blue line is the same thing as slope of a blue line is equal to 3 minus 1 over 2 minus 1, which leaves us with 2. So y is equal to 2x plus b. And we know it must pass through 1 and 1. So we have 1 is equal to 2 plus b, and b has to be negative 1. Right? So y is equal to 2x minus 1 is going to be one of the equations for a tangent line. We do exactly the same process for the red line. For the red line, we have a slope of 9 minus 3 over 3 minus 2. So that's 6. So we have y is equal to 6x plus b. But we know